So why the bad form? A gymnast is twisting and rotating and their feet come apart. Let's say they're performing a back layout with a full twist on the floor or trampoline, or they're doing a swinging half-turn dismount on the bars. It could be a bad habit while their feet come apart, or maybe they're not thinking about their form and they need to squeeze their feet together. Or maybe they're squeezing their feet together but they're not strong enough so they cannot resist the centrifugal force that's pulling their feet apart. Another factor affecting gymnasts is absorption. Absorption is the reduction of the intensity of energy. Now, absorption is not a law of motion, but it greatly influences the resulting movement on every event: tumbling, bars, beam, rings, trampoline, etc. The energy or force a gymnast creates comes primarily from the contraction of their muscles. The more relaxed their muscles are, the more energy they absorb, resulting in reduced force. In gymnastics, we want power, so we want to try to get them to be tighter. The tighter they can squeeze their muscles, the greater the force they can create. For example, a male gymnast must have tremendous strength in their muscles that they can tighten to accomplish a strength hold on the rings. For this example, I'm going to show a girl bouncing on the springboard. The concept is the same on the floor or even on the trampoline. And though the springboard has massive springs in it, she's not going to go up and down until she starts incurring force downward on the board. So for her to bounce high, what I want her to do is to keep her legs nice and straight. So you'll notice that she bounces really high when she's keeping her body straighter, contracting tighter. But let's say she begins to bend and absorb that energy. You can see clearly when she absorbs her energy, the board does not compress as much, she can't go as high. And this is one of the challenges that we have as coaches, getting children to vault higher or tumble better. When gymnasts are landing and bending a lot, they're absorbing the energy that they have, and so they're not going as high as they can. This concept applies to all movement: bouncing on a trampoline, swinging on the pommel horse, tumbling on the beam, or swinging on a bar. One of the most common gymnastics challenges for a coach is, how can my gymnast tumble higher, have a bigger vault, or cast higher on the bars? Understanding the laws of motion and the factors affecting that motion will help you solve these challenges as a coach. In this example, we're going to use a ball. One of the neat things about gymnastics is the gymnast is bouncing around instead of a ball. So all the factors and laws of motion affecting a ball are the same exact thing affecting your gymnast. She's going to bounce the ball, exerting the ball downward with a certain amount of force, and so it simply bounces back. What would we do to make the ball bounce higher? Yeah, you guessed it. Throw the ball down harder, and you can see that the ball bounces higher. But what if we could not move the ball faster, and we still want the ball to go higher? Yeah, you guessed it. We could throw that ball down from a greater distance. But what if we could not fall from a higher position or throw the ball down faster? Is there anything else we could do to go higher? Most balls have a nozzle where, obviously, we can put more air in the ball. Adding more air will make the ball have more bounce. So even if we don't throw the ball down faster or we don't fall from a higher position, if we added more air into the ball does become bouncier. The same principles apply to gymnasts as they do the ball. So in the most basic terms, for a gymnast to go higher or bigger, they must do three things: move faster, or squeeze tighter, or do both. Now at this point, I'm not accounting for the factors that affect their direction. That's coming later. But in its simplest forms, if you want your gymnast to tumble higher or have a higher vault, they're going to have to go faster and be tighter. Another common gymnastics challenge. As a coach, one of your challenges is to teach your gymnasts how to control their center of gravity. This will lead us to another factor that we must understand to help us coach our athletes. I'm calling this a gymnastics law of motion, number 1, although it's not something from Isaac Newton, but in its simplest form it describes this. The gymnast's center of gravity follows the opposite end of the force they are creating. This clip is going to show a girl doing a round-up flip-flop back layout. And in this case, you'll see that the forces she's creating are going down through the floor through her feet, which means her center of gravity, about her waist, is going to follow the opposite end of that force to do her layout. So we're using the first law of motion, the one that says once in motion, always in motion. This implies direction. The gymnast's direction, or her center of gravity, is following, in this case, her head and shoulders. The third law is also being used. For every action, there's an equal and opposite, meaning the amount of force downward is determining how high she goes. This next clip is another girl doing a round-up back handspring layout, but you're going to see she doesn't do it as well. So even though her forces are going down through her feet, her center of gravity is going backwards more, because you can see that she's arching her back, throwing her head and shoulders backward, so she simply will not go as high because she threw her head and shoulders back. So we're still talking about the gymnastics law of motion. That's not really a law of motion from Isaac Newton that refers to the center of gravity follows the opposite end of the force they are creating. But for this example, I'm going to use the uneven bars. This gymnast is going to do 2 giants to a flyaway. In this case, the forces are going down through her hands, which means her center of gravity will now follow her feet. So as she begins to do her giant swing, where she points her feet, her hips follow. She stays nice and stretched. She scoops her toes. Predominantly, as coaches, we see gymnasts arching here at this point, and that means their hips are going the wrong direction, making it more difficult. This gymnast is driving her feet upward, so she goes over the bar in a very nice shape. Preparing her for her flyaway, remember that the forces are going down through the bar, meaning that her center of gravity is going to follow her feet. And she does the flyaway perfectly. Let's talk about the third law of motion. For every action an object makes, there is an equal and opposite action. I'm going to use 2 gymnasts that are almost identical in size and height. I'm going to ask both of them to perform the standing vertical jump. The first gymnast jumps that high. The next gymnast, again, she's approximately almost identical in size and height. She jumps that high. So why does one girl jump higher than another? Well, we have to talk about the second law of motion. The greater an object weighs, the greater the force it takes to move it. But in this case, both gymnasts weigh the same. Then the third law comes into effect. For every action an object makes, there is an equal and opposite action. Clearly, one gymnast can create a greater force downward than the other. So one girl jumps higher than the other. So as a coach, we need to know, what is force? Isaac Newton created this equation. Force equals mass times acceleration, which basically means the speed in which a gymnast can move their body weight. Mass is their weight, and acceleration is speed. The faster a gymnast can move, the more force they can create. So the stronger a gymnast is for their body weight, the more force they can create. Another gymnastics law of motion is about rotation. To create rotation, a gymnast must change their body shape. The greater they change their shape, the faster they will rotate. Now, to start teaching about rotation and changing shape, I'm going to use an example of a girl swinging on the bar and doing a giant. Though the giant's a little bit more advanced, the concepts are still the same. A gymnast that does not change their angles has no shape change. They simply can't rotate. So to begin rotation, she has to start changing her shape. In gymnastics, predominantly, we use the shapes of hollow and arch because it's prettier than tuck and pike. If she tucked her knees and piked more in her hips, she could create more shape change, creating more rotation, but it's not very pretty. So we use the shapes hollow and arch over and over again, moving from one to another to create more rotation. The greater she changes those shapes, the more rotation she has. And this theory or this concept applies to anything involving rotation. This next video clip is a gymnast doing a laid out Yurchenko vault. Let's watch it. That's pretty nice. Now the laws of motion and the factors involved doing this vault are exactly the same as if a gymnast is performing a front handspring vault or if they're tumbling on the floor doing a round off back handspring. When she makes contact on the board, the forces are now going down through her feet, meaning that her center of gravity will follow the opposite end. So where her head and shoulders go, that's where her center of gravity or her hips are going next. To create a rotation, she changes her shape. So she goes into an arch, and a big arch, because she wants a lot of rotation. When she makes contact on the vault, again, if it was a front handspring vault, still the same concepts apply. The forces are now going down through her hands, meaning her center of gravity is now following her feet. To rotate off of the vault, she changes her shape again and goes to a nice hollow shape. She has enough momentum that she can hold that shape throughout and land the vault safely. If the gymnast was performing a flip or a salto on any event, which shape would rotate faster, a layout or a tuck? Yep, it's the tuck. Because remember the law of motion number 2, to create rotation, a gymnast must change their body shape. The greater they change their body shape, the faster they rotate. So this lecture has been about the biomechanics affecting gymnasts. So as a coach, you know gravity, centrifugal force, and absorption are some factors affecting the laws of motion dictating what they're doing. The first law was an object in motion stays in that motion until it is affected by another force. And the second law, the greater an object weighs, the greater the force it takes to move it. And the third law, for every action an object makes, there is an equal and opposite action. This has been the Gymnastics Law of Motion Introduction for Coaches for the USA Gymnastics University, presented by me, Tom Forster. Remember, coaches, wherever you are in your coaching career, education is the key to your success.